Hi, in this video I'm looking at this problem here where we're calculating the volume of revolution created by rotating this curve here, x squared plus y squared equals 64, around the y-axis between y equals 3 and y equals 8. Now if I have a quick sketch of this function is a circle, x squared plus y squared equals r squared. So I've actually got a circle of radius square root of 64, which is 8. So I've got this circle here. And I've got the bounds y equals 3 and y equals 8. So I want the area created between those two bounds. So I want that area there. And now this area is going to be revolved around the y-axis, which is going to give me basically a sort of a bowl-looking shape. Because effectively if I take half of it and I rotate it around, I'm going to get the base, and that's going to follow the circle curve up to the 8. So I'm going to get this basically not quite a hemisphere, but a bowl type shape. To do this, I'm going to use the rule that our volume is pi times the integral between our bounds of a function of y. That function is squared, and we integrate with respect to y. So I need a function of y, but currently I've got x squared plus y squared equals 64. And to have a function of y, I need to isolate the y with everything else and have the x on its own. So I'm going to minus the y squared from both sides, and giving us x squared equals 64 minus y squared. And then to get the x on its own, I'm going to have plus or minus the square root of 64 minus y squared. So now if I go to my rule, because now I've got a function of y. And so putting that into our rule gives us pi times, we're integrated between 3 and 8, so we've got 3 and 8, of plus or minus the square root of 64 take y squared, but then that's squared with respect to y. So if we sort out the square root and squared, it cancels out. And in fact, I could have just used this rule here and just forgot about that square, because I've now got the integral between 3 and 8. And with the square cancelling out the square root, I just have 64 minus y squared with respect to y. So now let's integrate this. Our volume is going to be pi times 64 integrates to 64y, and y squared integrates to y cubed on 3. And we're still between the bounds of 3 and 8. So now if we do our calculations, we're going to have pi times by, and we're going to have 64 times by 8 minus 8 cubed divided by 3. All minus off 64 times by 3 minus off 3 cubed divided by 3. So now what I need to do is work this out in a calculator. So I'm going to have pi times by 158.33. And then if we multiply by pi, we get our final volume. And that tells us that our volume is 4,973.42 cubic units. And we've got to write cubic units because we're volume, but we don't know what our units are. So our volume of our little bowl here is almost 5,000 cubic units, whatever that happens to be. And we got there by using this function for volume, which is pi times the integral between our bounds of a function of y squared with respect to y. We had to get our function of y, and then we integrated it, put in our numbers, multiply by pi, and got our answer.